Welcome to the Empowering Tomorrow's Automotive Software Podcast, brought to you by ETAS, a single source of cutting-edge software and hardware solutions that make automotive embedded systems safe, smart, secure, and sustainable. Each episode, we'll be joined by ETAS and industry experts to discuss how electrification, automation, and connectivity are impacting the automotive industry. Now, sit back and enjoy the discussion.
Hello, everyone. Welcome to another episode of Empowering Tomorrow's Automotive Software Podcast with ETAS. I'm your host, Suresh. And today I'm joined by Cedric Armand, Director of Virtualization at Ford Motor Company. Cedric brings over 15 years of experience in the automotive domain, from embedded software to controls, calibration, and validation. He's led breakthrough virtualization initiatives at GM and now at Ford, and he sits at Ford's center of gravity for shifting towards virtual first environments. Cedric, it's great to have you here, and we're looking forward to the conversation.
Thank you. Really excited to be here. Thanks for having me on.
No worries. So, Cedric, I'm going to start you off with a general question, and then we'll kind of go from there. I think based on your background, you've seen the evolution from going from a physical first testing mindset to now a virtual first engineering approach. I know for me, this is a challenge because I come from hands-on calibration, I come from hands-on testing. Now, to move into a virtual environment, why do you think when you joined Ford, this became so mission critical? What value is it bringing to you?
Yeah, great question. It's become mission critical for a number of reasons, right? Number one, software within automotive vehicles is just becoming so important, right? It encompasses like close to 50% of a vehicle's value, right? It's becoming more complex, and customers want software and software updates to have more features and to bring it faster, right? So realistically, the demands of where software needs to be and the quality expectations continue to rise. So we just need to continuously keep bringing more tools, methodologies, and enablements to deliver our software faster, have it have higher quality, and also be able to meet the challenge of how do we actually develop and validate and test, something that's growing in more complexity every day.
So how do you actually define virtualization or simulation? What is your driving factor behind it? What is the driving differences between what you would do traditionally versus what you're doing now in the modern environment?
Yeah. So let me put a couple of little nerdy definitions, right, and then kind of go into it, right. So virtualization, simulation, used somewhat synonymously, but virtualization is simply making a virtual version of some physical artifact or some physical system or some physical hardware, right. And then simulation is actually executing those virtual artifacts in a manner such that they behave the way the real physical system does, right? So the simulation is actually using these virtual artifacts. So virtualization, simulation, right? Huge fields, right? So if somebody's listening or is first coming across, idea of virtualization, simulation, right? They might be thinking of like VR headsets, right? Which is virtualization and simulation as well. What we're talking about specifically is virtualization simulation for the purpose of software development and testing. So that means you're kind of bringing three major or simple kind of components together. One is a virtual ECU, which is a virtual version of a particular software stack or the ECU in that software stack. Then the other group of artifacts you'll be bringing are plant models, right? And these are models of, the physical system with which you're trying to control, right? So very simple. It could be like a plant model of an engine, right? So you can have a virtual version of your engine controller. Then you can have a plant model of your engine. And then the third component is just some co-simulation platform that allows the control signals from your virtual ECU to talk to your plant models, and then feedback signals from your plant models back to those virtual ECUs. So now you have a closed loop environment. such that it will execute the software, you'll get feedback, and it'll operate similarly, if not, the same as it does in an actual physical vehicle.
So what are some of the expectations in respect to tooling to enable some of that stuff?
Very good. So there's a whole host of tools, to use and to enable this, right? So there are different tools, and we could talk about specific ones out there, off the shelf of the market, right? But at a simple level, you need a tool that allows that code simulation to happen, right? That allows the communication of signals back and forth. Then you need a tool or tool suites to virtualize your ECUs and virtualize your software stacks, right? And there's different levels and fidelities of virtual ECUs to do that. And then there are tools to make different types of models, right? So it could be plant models, which people are sure familiar with. There could be something, a Simulink based model, but whole host of different tools to make different types of models of different fidelities. But then you also might need other types of models, such as something known as like rest bus models, which is maybe models of other critical signals that happen within the communication network that maybe are not present in your environment, but you need to simulate to some degree, right? So if we want to talk about specific tool chains, we can, or types or examples, by all means. But there's a whole host of tools out there for sure.
And I think one of the things you mentioned is this is a closed loop system. So my expectation or my understanding is all these tools have to work together to build this ecosystem, right?
Yes.
So what challenges do you see in this interoperability requirement, right? This is definitely a change from what we do today.
Yes. And so the environment, the simulation environment I described, yes, was a closed loop environment, right? You can have a open loop environment, but the only difference is that you would have minimal number of plant models within the loop. So this is usually, those types of environments are used just to, maybe you're checking like diagnostics or communications or other low levels part of the software, where maybe you don't need that feedback loop, right? But even still, your question still applies, where the interoperability is very important. And earlier, or years ago, interoperability just didn't occur, right? And that was okay, right? Because the solutions were kind of very singular, very pointed, right? Some OEMs started creating solutions kind of in-house and from the ground up. Companies started creating solutions, right? And they were very, very focused, right? But now, as the ecosystem is growing, right, no one company or tool chain can really truly satisfy all that is needed in a virtualization simulation, all by itself, right? So, and different companies are going to be better at certain things. So it is very important to have interoperability between tool chains that make virtual ECUs, that communicate signals, that serve as platforms, that make plant models. So as it becomes more important, right, we need to have certain standards that we kind of work towards. But then also just understanding that, if there's a tool chain here, it needs to work with, these other tool chains out there. And, you need to have like open APIs to be able to have that interface.
So when we talk about simulation or virtualization, what we used to do on a PC was very simple, right? You load it on your PC, you run it, and you get some output. When we're talking about this big closed loop infrastructure or environment, the compute power seems complex and heavy. So where does Ford kind of operate this environment? Is it in a cloud environment, or is it in some kind of hybrid blend of the two? Where do you currently operate it?
Yeah, great question. So you're right. When I first started, and even still now, right? You can do things on your PC, but realistically, at an OEM and even, like tier one suppliers, right? Virtualization and simulation really needs to be done at scale, right? So let's just think about that for a second, right? At Ford or any OEM, our vehicles average, say, 70 ECUs within it, right? So think about all these different software stacks, just as a general concept. But then, we have different model years. We have, different specific vehicles lines, right? And programs that we need to, right? So there's a whole lot of software, a whole lot of different simulations you try to run, and, they become intensive, right? So realistically, running this on PCs is not the way to kind of industrialize or scale that up, right? And so you need to have a cloud-based platform with which users, internal users who are trying to use these environments to develop and test their software can be able to access these environments and these virtual artifacts for their testing, as well as whatever testing pipelines and that they might emphasize, just so that, and this serves two purposes. One is that now you're more easily able to share environments between two users, right? So let's say you and I, Suresh, we're working on a gateway ECU, right? And we want to develop the software, and we're developing it together. We want to be able to share that environment and kind of use the same thing, right? And so it becomes very easy, right? People don't realize it if they haven't gone through it, but if I have a bunch of files on my computer and I say, hey, Suresh, I want you to look at the same thing, I got to zip all these files or post it or whatever and hope you put all the same configurations exactly right. Chances of that working out are slim to none. But if you have it hosted on a cloud somewhere and somebody accesses it, boom, okay, you pull down, you make like a duplicate copy, I do the same thing. Now we're working on the same thing. That's one part. The other part is virtualization and simulation have an immensely high return on investment, right? But they also have a high initial investment to get it to get it to work. So you increase that return the more you scale, right? And that means you want to be doing more and more testing, millions and millions of testing. And frankly, in automotive industry, right, we do not test our software nearly as much as we need to, right? There are different thoughts, within the industry about what it is, but a rule of thumb that you would hear is you want to spend 50% of your effort developing the software and 50% of your effort testing it, right? And so you're not realistically, companies are just not going to hire as many, let's say, software testers as they are software developers, right? But you can reach that ratio by being on a cloud-based platform and being able to run, millions and millions of tests overnight, regression, kick those off, right? And just leverage, having, big server farms.
So maybe I want to touch on the ROI topic again, right? You mentioned that the return on investment long term is huge.
Yeah.
What are some success factors that you believe need to occur to reach that ROI? And what are some of those investments you need to do upfront in order to get this type of environment functional? For example, I know, navigating plant models and integrating them into software in the loop environments, there's a challenge there, right? But is it mostly human effort, or is it infrastructure effort that takes more time to get set up?
This is what I'll say. Having gone through this, having benchmarked, other OEMs who have done it, right? Generally, an approach that works is creating a cloud-based platform where users can access and have different workflows, right? And then you need to have an infrastructure to virtualize, your ECUs, right? To make virtual ECUs to use. And then, you need to have a way of developing the necessary plant models. And then you also need the effort to integrate them to make these environments, right? So technology wise, to, let's say, get the platform and get the infrastructure and things like that, right? You can get that up and running. That's been done. There's ways to optimize it. There's companies, there's partners out there, who've done this a couple times. Within organizations, you need the human power and the organization structure where you have engineers who know how to develop virtual ECUs, engineers who know how to make plant models, engineers who know how to integrate them into environments, right? To set those up for users. And then the users, need to get brought up to speed on how to use it. And then there's the culture aspect, right? Where with that, I say, this is a change, right? So many years ago, when hardware in the loop or hill benches first came out, right? Nobody wanted to use those because everybody wanted to do things in vehicle. We fast forward,
Right.
and, right? Everybody, wants to just use hill benches, which they're good, right? And maybe it was like 10, 15 years ago when software in the loop started coming out, right? Nobody wanted to do that. Started to gain a little steam. And now there's like this next evolution of software in the loop where it's really becoming a bigger, grander scale. You're working with different fidelity levels and abstraction levels of virtual ECUs. And so, that's a bit of a cultural change as well. And also part of that is not only using different tools, but hey, now you got to start developing your software earlier, right? Now you got to test it more, those things, and have integrated workflows. So that part of it has to come along as well. So all of it needs to come together for it to be a success.
So when we're talking about the business side of it, right, we're asking management for huge investments.
Yeah.
We're going to promise you this ROI.
Yeah.
But the first question they're going to ask you is, all right, how do I track my investment? What are the KPIs that I would see as success factors, right? So in your role, what do you see as things that you would track in order to say this virtualizing this platform into this ECU and these set of vehicles or whatever it may be, this is how I know that I'm doing better than I was previously. What are some of those success factors?
Yeah, absolutely. So, the main benefits of virtualization and simulation, at scale are and this is there are industry proof points, right? But one is you're going to shorten your software development time by 10 to 12 months. You can also shift it to the left by 10 to 12 months. And then the third, I think I said two, but it's really three. The first two are related. And then the last is you're going to shift your defect discovery or your software bug discovery to the left, right? And I want to get into that a little bit. Anybody who works on software, develops software, knows that you're going to have defects, you're going to have bugs. It's just the nature of developing it, right? And when you're doing that, it's just about, are you going to discover them in time and early enough when it's cheaper, right? So if I write a piece of software right now, but I find that bug, tomorrow, fairly cheap fix, right? But if I write a piece of software today and then 2 years, I don't find that bug until that vehicle is launched and it causes a warranty problem, right? Very expensive to fix, right? So the idea is it's cheaper the earlier you find these defects. And it's again an entry proof point where virtualization at scale kind of shifts the bugs that you find, let's say, at a system integration phase and a production and beyond phase, by like 65% of those bugs are found earlier, right? So if we think about that, right, and then the KPIs we want to track, right? So one is easy. You want to track your bug and your defect discoveries, right? And when they are happening and how many are being found through specifically virtualization and simulation based testing, right? That's an easy KPI. The other that you want to track is, how quickly or what your time is from, let's say, software feature, started development to validation, right? So not that a company would do this, but let's just say, if you had, two different software organizations within your company, right? You track one that's not using virtualization and say, you track how long it's taken for it to develop a software feature and validate it on average. And then you have your parallel company, your parallel organization that is using virtualization, and you track how fast that is, right? You're going to see that difference in time. And so, tracking that as a software organization and companies is critical, and that's where you'll see that benefit.
So I think I understood, we could probably move things to the left. So maybe regression testing can be done in a software loop environment. Diagnostics, fault injection, these are probably things you can do. Having different variations. You can do explosion testing there, right? Mixing and matching.
Yeah.
So there are things I believe that you can do in a virtual environment, and there's things that you still cannot, right?
Correct. Yeah.
I believe there's things that are still time dependent, safety critical, things like that that still require physical validation. Yeah. So what percentage of development have you realistically been able to move virtual today? What are you expecting to move in the next years? And how much will still require physical validation? So how much are we still requiring, hill and vehicle validation for? How much can we actually move up front into a software development environment?
This is a really, really good question. And I have seen it because over the course of my career, I did software development and I was at a point where like software in the loop really kind of came in and I saw, what things we can do. So, when I was doing software development, I would kind of do some basic steps where I would first, develop my algorithm and then say test it just like a little Simulink model. Then I would compile it into, a virtual ECU and into a software in the loop environment, test it there. Then I would take it to a physical hill bench. Then finally I would take it to a physical vehicle, right? So that was like my workflow, and I think that's like a good way to do it, right? Because you're going to find different potential problems and gating at the different types of testing or different ways of testing your software. But that was like my experience and what I've seen, and so I continuously kind of benchmark and look at like research and see what other OEMs and tier ones are finding and what they're kind of shifting, right? So the most optimistic of people say, you can do like 90 to 95% of your testing, I'll say between software in the loop and physical hill benches, right? But a lot of that being with software in the loop. But I think it kind of breaks down where, development and unit testing, by unit, I mean like you're testing like the actual software just running on its software stack, right? So kind of code verification, algorithm development stuff, right? Like 99% of that can just be done with software in the loop, right? Virtualization, simulation. Integration and function testing, right? So how it integrates into maybe a bigger system and how some features are actually functioning. You're probably at like 70% of that can be done, with software in the loop. Now, when you mentioned, like safety critical, so validation and safety testing, that's probably 50-50, right? Where, you need physical assets to do it, 50% you could do, with virtualization and simulation. But no matter what, you always want to do, final vehicle verification testing, right? Or at the very least, final physical hill bench testing, right? You always want to do a final physical test, right? And that will always remain because you always want that last step before that software goes to the consumer.
So we talked a little bit about your experiences, right? What you've been able to experience in your past and what you're doing today.
Yeah.
So first off, what kind of surprised you, maybe from a virtualization perspective, right? What
Yeah.
did you think maybe was more difficult to do that you were able to do? On the other side, what did you think that you could do that maybe became more difficult to do, right?
Yeah.
Because I think we can all speak to saying, oh, virtualization looks like a great vision, and it probably is. But there are still limitations today, right,
Yes.
that prevent us from going completely 100% virtual.
Yeah. So probably the most surprising thing. So this is the first is not technical, it's actually return. So when I actually looked and started to research what the actual true return on investment is, I was surprised by how much it is. And it makes sense once you do the math, but when you kind of think about like the value of being able to deliver software, say like 12 months earlier, that first time to market value is immense, right? So just think about, let's say you have 3 different OEMs, right? And each of them today says, man, I figured out how to make a flying car, right? Whichever company is able to get that to market first, is going to win, right? It's just straight up, right? So, that value is huge. But on the technical side, what was surprising to me was I always thought of like virtualization simulation as, hey, those results need to match the hardware. But what I found kind of maybe fairly quickly is no, they don't, because hardware is not repeatable, right? So, when you have a physical ECU that is running, right, it's going to have, capacitance and resistance and be affected by temperature, and whatever setup, that is on a physical hill bench, right? If I work on a physical hill bench today, okay, great. But then, Suresh, when you come and work on it the next day, you're working with whatever I left over and whatever mess I made on that hill bench, right? And so it's not repeatable, right? So you're going to find issues, right? But there are some issues that you will only reliably find in virtualization simulation because that virtualization simulation is just software running software, and software is repeatable, right? It runs the same thing again and again and again, once you take the physical hardware aspect out of it. So that was one of the surprising things I found, and I was like, oh wow, it does have benefits where it's like you're just going to find some things that you're not going to find in physical hardware. And this becomes important because so many times, and even till today, right? There will be issues that come, back in the field or even in like, late stage development testing that they're not repeatable. Like something happens, something weird, a customer says something, and then it's like, "Ugh, we can't repeat it, or a problem not found when it's at the dealer, right?" And there have been enough instances when I started using virtualization simulation where we found issues that it was like, yeah, we didn't find it, we didn't see it on the hardware, but when we dig in, it's like it is truly an issue, and it's like, man, that's one of those issues that was going to bite us, in a year, and we weren't going to know. It was going to be a pain to figure out. So that's one part of your question.
So where's the limitation, right?
Yeah.
Where do we believe that we, no matter what, still need to go back to hardware, right? Where is the interaction with hardware that's still needed?
Yeah. I mean, there's at the end of the day, it's just like a general limitation, where I think people kind of understand inherently where virtualization simulation, you're still just replicating the hardware, and you're never going to get that exactly right, and not only that, when you have virtual models and simulated environments, they're always like works in progress, right? And so really the way to use those effectively is, first, let's say you have a virtual ECU, right, which is obviously mimicking or simulating your software stack. And so let's say you get your first iteration of your virtual ECU. So you take that and then you start developing your software. Right? Now, that software that you're running on your virtual ECU or as your virtual ECU, it is also like validating your virtual ECU model, right? And then so it really ends up becoming this iterative cycle, or a kind of one hand washing the other, where your virtual ECU is being used to develop your software is being used to develop and validate your virtual ECU, and you kind of go around and around this iterative loop each time, iron sharpening iron, each model and each software iteration getting better. So just understanding that it's never going to be exact, and it's like always like kind of a work in progress. We understand that you always want to do, at least one final physical verification, to see that you covered all your bases.
That's really good insights. So, I'm at ETAS, and ETAS, we're still growing into this virtualization journey,
Yeah.
right? And I think a lot of people that are going to be listening to this podcast are going to be interested in understanding what virtualization means.
Yeah.
There's also a portion of this which is cultural and organizational. There's naturally people who are going to have a lack of trust in the results that come out of a virtualization environment. Based on your experience and based on how you've managed to grow your organizations into this world, what are some key messages that you would give to those that are, I would say, not believers, but not full on, they're not fully absorbing it yet. They're not into it, right?
Yes.
What motivational words would you say that this is why we need to do virtualization, and here's kind of the evidence to say this is trustworthy?
Yeah. So I'll say it like generally. I forgot who exactly said it. Maybe it was I think it was maybe the CEO of like Rivian, right? And he was talking about software defined vehicles, right? The latest and greatest in vehicle software and EE architecture. And he said something to the effect of, in I don't know, 5-10 years, he does not imagine how a automotive company is going to be able to successfully, sell vehicles and be in the marketplace without having an SDV architecture, right? Just because it's going to be very difficult to meet the demands and keep up with all the OEMs who do, right? And I say the same thing about virtualization simulation, right? I don't see how, right? Um, a automotive companies, right, or software companies in general, are going to be able to keep up if you do not employ virtualization, right? If Ford, right, is and obviously, this is a competitive market, but I'm just saying, if any OEM company, right, if Ford is employing virtualization at scale, right, and developing their software 12 months faster than OEM B, right? How are you going to keep up, right? If one company is delivering their software features, earlier, if they're finding, their bugs, and they're saving money, on quality, and able to take that money they're saving and investing it in other places, how are you going to keep up, right? And so the limitations are absolutely true, right? But it's just, as long as you understand them and mitigate them, right, and then use virtualization simulation in the way it's intended, right, and do the right kind of tool or simulation for the right type of testing, right, then you find the benefits. And so anybody who is skeptical, I mean, you can ask the deep questions, like, what is the return on investment? What is, all those things, right? And you can go into those deep discussions. But I just would just ask the person in general, all right, if you're not going to do this, how are you going to deliver your software, a year faster, right? How are you going to get your bugs and defects down, to that rate? And
So it's really, it needs to be both a bottom up and top down approach, right? There needs to be some factors pushing from above, but at the same time, there needs to be buy-in from the bottom, the actual users to say, this is what I need to do to be successful.
yeah, and from the top down, right? I think leaders need to, be saying, hey, we're gonna improve our software quality, by X amount, right? And we're gonna deliver our software, faster by X amount, right? Right. Put that pressure on your organization, and
Mhm.
then, but then also enable them, right? And then the software developers and kind of middle managers, right? They'll say, okay, this is pressure, right? And then they need to say, okay, this is the solutions I need to meet those demands, right? And one of them would be virtualization and simulation. And then the leadership has to say, okay, I will give you the money to invest. If this is what you say you need to meet what I'm asking, then here's the money, go and use it, et cetera, et cetera.
So virtualization is an exciting space, right? I think it's a lot of things going on there.
Yeah.
But there's a buzzword running around right now with AI. Where do you see AI kind of not just improving the efficiency, but maybe taking some of the burden from some of the early investments and making it simpler to allow AI basically enabling you to be able to use virtualization faster?
Yeah.
And where else do you see AI playing a role in this space? Like maybe with test generation or fault analysis, or where do you see that? Where do you see it really growing?
Absolutely. So I'll get like well, I'll say generally, right? I think everybody is familiar with AI in different ways, right? And that it can just be an efficiency gain in what you're doing, right? So if your job is to write test scripts, right, maybe it can write test scripts faster or code it for you faster, right? Do things, right? It could just be an enabler in general. Very specifically, there are two use cases. One that kind of realized as more of an adoption tool, but another was as a use case as an efficiency gain. So the efficiency gain I'll say is when a software developer or tester is using a virtual environment to develop their software, right? And they develop some software and they run a test, and let's say that test fails or some unexpected results, right? When that happens, to be frank, right, you do not know if it was a true software bug, if there was a problem with the virtual ECU, if it was a problem with the model or some models that were within that environment, or if it was a problem with the test script that ran the test, right? So there's a number of things that you have to do what I call like a first level triaging to figure out, hey, where is this issue coming from, right? And that's the honest thing that occurs in any type of testing, right? And AI, and I've seen this demonstrated, that is a very good tool to use to do that first level triaging, right? Because you can train a model to know some things initially, but then every time you run a test, and especially when it fails, right, you can take that information, right, and continue learning so that when it happens again or something similar, right, it starts to learn so that yes, when a test fails, you know I'm making it very much more simple. But at first, it pops out and says, your AI agent comes out and says, "Hey, I think it's a test script issue. Go look at this." Right. So at least it points you and helps you kind of guide you a little bit faster. That's one aspect. The other is which I guess is simple, but just kind of AI agents where at scale when you have a virtual platform and you have virtual environments and test suites and tools and everything, all that stuff, right? It's a lot for a user to come on board and figure out how to use it, right? And back in the day, we used to have physical manuals, right? Then we started to have help functions and tutorials that are online, and now it's like, there's no way I can read through or understand, right? And so just to like learn or figure out how to do something, whatever, right? You just ask your AI agent that's attached to, say, your virtual platform, and that's going to enable users to adapt or adopt the methodology and the tools that you're bringing to them much easier and faster.
Nope. So we fast forward 5 years, right? You've been in this role at Ford. What does virtual first or virtual Ford look like 5 years from now? What would you consider will be a success factor for you?
Yeah. So in 5 years, this is assuming I don't win the lottery, right?
Yeah, exactly.
I'm just grinding it in this role. Okay.
Or maybe you're so passionate even after you win the lottery.
So passionate. I win the lottery, but I'm still in it for the love of the game. All right, let's go. All right. So in 5 years, right, what I would expect is we have like a fully mature virtual platform. So meaning www.forvirtualization.com, where our internal users as well as our tier one partners are able to go in and access all the virtual artifacts they need, as well as the tools they need, environments, etc., tests, to do their software development and their software testing. Right. In 5 years, I want to have at least half of our software developers within Ford, using the platform, actively, right? So having it be used at large scale. In 5 years, I want, our cloud provider bill, to be high, meaning that we're running millions and millions and millions of tests, right? Valuable tests, obviously, but the point is that we're investing and we're using this at scale. And then as we develop new software stacks, new vehicle architectures, right? I want virtualization to be at the forefront, to be um, used at the very outset, so that we make the right decisions early enough, right? We learn faster, right? We don't have to wait on hardware, to kind of figure out some things. So that's where I hope for it is in 5 years.
Can you do it alone, or do you need partners?
You need partners for sure. So, I'd say to develop like a platform. So, like kind of like the platform that users kind of hop on. There are partners who know how to do these things. There are some off the shelf solutions, from like engineering service providers, right? But you want to leverage their expertise, right? You can do these things in house and whatever, but it's just not going to be as good, right? You're not going to have the lessons learned from other OEMs, right, and the general industry knowledge, right? So you need that. You need cloud provider partners, right, who are invested in automotive solutions, because they will have frameworks and have done this before, right, to kind of enable and go faster and have some lessons learned. You need like tool chain providers, right? Like ETOS, others who work in the co-simulation and simulation, to provide their tools and bring their tools that you naturally use on hardware to have versions that can be used in virtual environments and are cloud native. You need partners to create virtual ECUs, right? We didn't get into like the different levels of virtual ECUs, and that's okay, right? But there are different partners who have expertise in having hardware emulation, levels of virtual ECUs, and that expertise, right? So you definitely need a lot of partners to make it work. And the other benefit of not only getting it to work is that if you do it all by yourself, or more by yourself than you probably should, it's very hard to stay on the forefront and the cutting edge, right? You mentioned, virtualization is exciting. It is exciting. And it is because it is always evolving, and new things are being added, right? And so being aligned with partners helps you kind of stay on that cutting edge and continue to bring innovation to it, right? So today, I might know, hey, these are all the best things in virtualization and simulation. That's great, right? And even if I, win the lotto and I'm still doing it for the love of the game, I can, yeah, sure, stay on top of it as best as I can. But it's too big. It's too big a space, right? There's no way, right? And also, I'm not going to come up with all the best ideas in the world, right? So partnerships are not only vital, they're just absolutely necessary, right? You can't do it.
I fully agree with you. I think we're in the same mindset here at ETAS, right? There's things that we know what we're capable of, but there's also others in the industry who know what they're good at. And if we want to get to market faster and we want to be able to supply companies like Ford with the right tooling, working together with others to build a common platform or common ecosystem, I think enables everyone to be more successful.
Yeah. When I first got into, I'll say, like automotive and like controls and software development, right? Got introduced to ETOS and Inca, right? Everybody knows Inca, right? Use it for calibration and things like that. And now, at the point where it's like, okay, we want to do calibrations and do it virtually, right? It's like, well, obviously, we partnered with, our companies would partner with ETOS, for the calibration solutions, and now you're saying, I want to go to ETOS and be like, hey, I want to make sure I'm able to do this in virtual environments as well, right? So some of these partnerships are like kind of continued, and you're kind of bringing maybe companies or partners who, we're really successful in the hardware space, and you say, hey, this is where we're going. We want to go there, right? And some are who kind of natively just kind of focus in on virtual solutions and things like that.
Mm-hmm. No, I think that's a great insight. Well, Cedric, I think that was excellent discussion. I really enjoyed the conversation. I think we got a lot of insights into what your vision is and where you guys are heading towards. Really appreciate you jumping on here and having this conversation and kind of bringing all this information really to all our audiences. So appreciate your time and definitely your willingness to join.
Absolutely. Really appreciate the invite and having me on. It was a lot of fun. I do geek out on this stuff. I do it for the love of the game. And so, hopefully, you'll have me back at some point.
We definitely will. I'd like to explore more of this journey as you go through it, right?
Yeah, fantastic.
All right, well, thank you. Thanks for everyone for joining.
Thank you for joining this episode of the Empowering Tomorrow's Automotive Software podcast. Please leave a comment or review with your feedback or what you'd like to hear in future episodes. To learn more about automotive embedded systems and ETAS's capabilities, visit our website at ETAS. That's ETAS.com.